Okay. Hello everyone. Let me maybe do this. No, never mind. There we go. What's up? Hopefully you guys are doing well. This will be a 3-hour stream, or around 3 hours. And then yeah, we'll be doing some Fourier series. Very exciting stuff. I did have a lecture on this last week, Friday, I think. And yeah, I just wanted to read the text. I haven't read the book, so that's basically what I'm planning to do. I haven't really prepared. That's all I prepared, I guess you can say. Okay, these are the stats stuff up here in the tab. Let me try to open the book. Wait, maybe I should open it here. But I won't start right away. Let me just prepare it. It was nice to see some people waiting for the stream. Usually never happens these days. But also I've seen that subscribers or new subscribers are coming in, which is also very exciting. So yeah. Hello, a girl named Nirak. It sounds like, if you've played Skyrim, it sounds like Mirak. Which probably doesn't make sense if you haven't played Skyrim. But hopefully you're not as evil as Mirak, which I don't think so. Anyways. First year uni, oh no. And I mean, I think Mirak was evil, right? I mean, he was a bad guy in the game, at least, in the DLC. Where am I? Okay. Downloads. So it's the Vretblad. This book we'll be working on. Maybe I'll make the thing smaller as well. Cool. Hello, Aisha, or Aisha. Fellow mathematician. Hello. Are you in your first or second year, or where? Like, what are you studying? I'm guessing you're doing maths, but like, what year are you in? Hello, Farah. How much time you? I'm not sure what you mean. How much time will the stream? Like, how long will the stream be? The stream will be, I'm thinking 3 hours. And yeah, we're gonna start on chapter 4 on Fourier series. And I'll probably hate myself afterwards. No, probably not. I feel like if you have like, I feel like I have okay background with series and stuff, so I don't think this will be that super unintuitive. Maybe I'm wrong. I remember also I began reading this, at least chapter 4.1 during the summer. Hello, Watashiwa. Sorry, I didn't pronounce that correctly, probably. Okay, let me scroll down. I just learned today as well how to do how to make Twitch clips, which is very fun. And I mean, I can see how. I mean, to make a good clip, you need to be kind of straightforward. And I noticed that I remember I did have some good moments, but they weren't really clip worthy, I would say. Maybe we'll get some clips today. And if you do find like a good clip you wanna like make, just go to Twitch on the live stream and you can click make clip, and then you can just edit it. Takes 2 seconds. I spilled water everywhere. clip that. No, maybe not. Okay, Fourier series. We're going to solve, so we can see the approximation problem that was presented in section 1.4. So let me just recall what that was. Yeah. Strategy will perhaps be somewhat surprising. Start with the function which will define a certain series, and in due time we shall find that the function can be recovered from the series in various ways. All functions that we will be considered will have period 2 pi. The whole theory could just as well be carried through functions having some other period. It's going to the standard case that we treat. Yeah. A simple linear transformation of the independent variables, the formulae that hold in the general case are collected in 4.5. Okay. Okay, so this is, okay, so T is, as I understand it, just a complex unit circle. I'll just call this Fourier series. Is it Fourier? Hello, JK. Over an interval of 1 period can be written statement f is continuous in f of t must mean that f is continuous at all points of the circle. If we switch to viewing f as a 2 pi periodic function, this function must also be continuous. Defines a function that cannot be made continuous on t at the point on t that corresponds to t plus minus pi. Right, so that would be a function like this, and it would be like that. And it's not periodic since, or I guess it is obviously periodic, but it's not continuous at this point. Can I join in Discord? Is it Discord active? Because I want to join if possible. Yeah, it's totally, yeah, you can join I'm on the livestream voice channel, so feel free to join there. I'm usually always on livestream voice channel on the Discord. I think you just need to verify your account. Okay. So saying that f is 2 pi periodic on R is the same as saying that f is in T, capital T. I'm not sure how to do that. So saying that f, if we say that f is C1 of T in T, it needs to be that f is periodic on R. It's continuous and periodic on R. 2 pi periodic on R. What's up, Sumu Hakare? Welcome. That's what I'm getting. Yeah, so if we switch to viewing pi as 2 pi periodic function, this function must be continuous. The formula blah blah, for instance, defines a function that cannot be made continuous on T at the point on T that corresponds to the limit f from different directions or different. Indeed. Similar care must be taken when speaking of functions belonging to ck of T. I haven't continuous derivatives of order up to including k. As an example, the definition describe a function that is ct but not c1t. Or I guess I can. So let's looky. Yeah, so it would be like such a function. And it is good. But if we take the derivative, we get the same situation here. Or roughly the same situation. A little bit different. The derivative does not exist as at t plus minus. The first derivative does not exist at. Yeah, I guess that's true as well. Yeah. So it cannot be C1 of t, which can be seen graphically by drawing the periodic continuation. Yeah. Let us now do a preparatory maneuver. This is some of the series. Okay. We assume that the coefficients are complex numbers such that they converge, absolutely converge. Likewise, for instance, the series actually converges absolutely and uniformly. Since this is always equal to 1, each term of the series is continuous and has period 2 pi. And as some function f inherits both of these properties. Right, so this f of t converges uniformly. Is it true that, I mean, each of the term is continuous and has period 2 pi? Then it means that the sum also is. I mean, I guess if it's a finite sum, I'm happy, I guess. But when it's an infinite series, so what does it mean to be 2 pi periodic? So if it's 2 pi periodic, we have that I guess we can define it as being, for any a, no. Right, so we can say for a number a in wait, let me just think. So I'm automatically thinking about the area here, so negative 2 pi to pi, but we can have any interval, right? So we can start anywhere. Maybe I can just say this. So interval I such that the size of I is 2 pi. For a in I, n times a is always equal to a, and some integer. Math is in the spot. Hello, dude with skepticism. So here we would have an a equal to right, so we would have some integer times t, blah blah blah. Alright. And this is obviously also 2 pi periodic, which I guess right, yeah, so it makes sense. Okay, yeah, I guess I'm convinced. Ay. So if we multiply it by e to the negative imt, it will still converge uniformly, and it can be integrated term by term over a period, such as just go through this slowly so I'm not overwhelmed. So we can multiply by this, and we have that this guy I mean, do we just use the M test again, but can we bound it? I mean, the size of this, yeah. Well, I'm kind of thrown off by a minus sign, honestly. But maybe it doesn't really matter. But, I'm thinking, can we even bound this? I mean, if we use the definition directly, I think we're fine, but I'm a little bit unsure. I guess. Oh, yeah. Sorry. I'm dumb. I'm done. And then we can integrate. I mean, it's yeah. So we can just do the M test again, and we'll get something cool. What's on the agenda? Oh, I haven't got an agenda for some reason. Is the agenda here? Yeah, it is. By the way, this is a bit of a different OBS setup. So wait. Basically, I'm just gonna have one. Bro, I forgot how to spell Fourier series. It's a Fourier. It just looks weird. I think that's fine. Cn is less than f. Isn't this just a Parseval's theorem or whatever? Just prove that the exponent in I and x is an orthogonal basis for L2, bro. I mean, this is not, I don't know if this is, it's not necessary. We can just use the M test, right? I don't really know what L2 is. They haven't really defined it. That's above my my expertise currently. But I think M test works fine. Anywho. Yeah, I'll try not to block the text as well. So we're here. It can be integrated term by term over a period. Yes, right. Right. Since it's continuous, and if we have a compact interval, we can. Yeah. I agree. Yeah. So it's f of t times e negative imt is continuous, and I think actually. This is maybe a tangent here, but if a function converges uniformly, then we know that the function will be continuous. I think that's a theorem. Let me just look. Maybe this will be a bit weird for people joining, but just some theorem I recall. Because if something in a course I did before, if something converges via any p norm, the function is not necessarily continuous. But if it converges uniformly, then it's really, really good. He's so good. Oh, it's not here. Bro. Yeah, so this is how I learned to stop worrying and love open balls. Exponential I and x is shorter basis for L2. I'm not sure what that means. What does shorter basis mean? And what does L even mean? I'm not familiar with that notation or the theory with that. Yeah, exactly. This is basically the proposition. The proof looks kind of scary, not gonna lie. Or maybe not. Add by 0. Okay, I'm not gonna go through that. Uniform convergence is continuity limit of sequence or all continuous functions. Exactly. Yeah. So if we live in the vector space C, like continuous vector space, then the limit will be inside the same space. Okay. So we can put the integral inside a series. Completely legal. And we can integrate this, but it is readily seen that this is equal. Wait, let me just write this down. Negative pi EIKT equal to okay, yeah. So when it's 0, it is obviously 0. All of this becomes 1, and then we have this, which is 2 pi. If it's non-zero, we have I'm not really sure what this means. Is this, do we view this integral as a like as a like a flux integral, I think? You're working towards the L2 theory, lol. Yeah, exactly. I mean, yeah, I think so, at least. I'm not really sure. You know more than me. Bro, I don't know what you mean by L2. Sorry, if you're wanting feedback, I have no idea. You'll have to define it if you want a conversation. I'm not sure how you would interpret this integral. Not gonna lie. Let me just recall. Lebesgue measurable function such that the integral of its squared is less than infinity. Alright. Well, Lebesgue measure is not something I've done. So yeah. So the 2 means this is squared. So just L would be, I mean, I guess it makes sense. L Lebesgue for Lebesgue measurable functions that are absolutely, or that so yeah, you would say that it's absolutely integrable. It's good for F and G. What do you mean by Kong? I mean, I don't know. It's not. I'll just ask ChatGPT what it could be. I mean, we can view it as a like a as it in R2 like. Okay. Yeah. Okay, that makes sense. So it's just component-wise, basically. So in this case, you would have or let me just and between pi and 2pi, these both functions are 0. So yeah, I am convinced. So when they are 0, we have 2pi, or when n and m are equal. For any absolutely convergent series of the form 4.1, coefficient can be computed from the sum function using this formula. This can be taken as a motivation of the following definition. Okay. Called Fourier coefficients, and the Fourier series of f is a series ew. Well, first of all, let me just... So it says that f is an absolutely Riemann integrable function over a period. Think of functions as vectors here, yeah. Yeah, I think that's the best thing. Yeah. Okay, so we have that. It's absolutely Riemann integrable. The Riemann integrable of f, the absolute value of f should be finite over any interval, right? So yay. Right, so if this series is absolutely convergent, then we know how do we know that we can take the integral here? Fourier series is infinite sum. Well, okay, let me just write down my thoughts, because otherwise it'll be a mess. So we have a series that is okay. So how can we know that the integral of this I don't really get, how do we know that this integral exists over some period, Well, let's think of this. Wait, let me recall a wait. I think it was somewhere, or maybe it was. I'll use this book for theorems. Oh yeah. To be able to flip these, we need to have that. Or wait, let me think. Does this converge uniformly? What is my answer or question? Yeah, Marcus, so probably you know this. In this text it says so we did some calculations, I guess, here. If we have a series on this form up here, and we assume that these guys I guess you can say that they're absolutely convergent. Then we have this formula for the CMs. But here we say that thus for an absolutely convergent series of the form 4.1, how can we know that the integral, that we can interchange the integrals here, only assuming that this series is absolutely convergent? Wait, oh yeah, I think I know. Yeah. So yeah, of course. Right. So this could be written as this, and we assume that if we assume that it's absolute convergent, we know that these coefficients, they're absolute convergent, meaning that we can use the M-test like we did before, showing that the entire series or rather showing that ft up here is converges uniformly. Right. Then we can interchange them. First note that, yes, exactly. I kind of yeah. And then in definition 4.1 we have that saying that it's absolutely Riemann integrable over a period, which is it necessary? I mean, okay, first of all, we don't mention that f is on any form in this definition. We just say that it is absolutely Riemann integrable, which in this case it is. Like this function is, I guess you could say it's, wait, let me think. Right, so essentially we're just saying that this thing converges when saying it's absolutely Riemann integrable, or maybe not necessarily. Let me think. I mean, we would say something strong. This would. I mean, certainly saying that this converges is, oh, can you see? Yeah, saying that this converges is stronger than this. So yeah, it's like saying something stronger. Absolute integrability used to justify the M-test or whatever. No, I don't think so. I don't think we use, like, saying it's absolutely integrable just means that we can do this integral. Or wait, let me think. Yeah, we can just multiply it by e to the imt. Wait, let me think. Yeah. Wait, let me. Okay, well, I don't know if this is that important though to get to justify the definition. I mean, I think we just move on. By the way, good night, Aisha. Yeah, hope you'll get a good night's sleep. I think we do. Because m-test assumes that this is for all x. Then you take the integral of both sides. Wait, so you're saying that you know that I'm not really sure if I understand. I'll just move on. It's an interesting definition. I mean, the whole goal was to justify uniformity, so that is so that we can interchange the integral and the sum now. Yeah, well, I mean, I myself I'm a little bit confused here, because we're not assuming that f is in any form. I mean, if we were to recreate this argument, I mean, let's try, I guess, like, I guess the question is how do we get this? Or maybe we don't, I don't know. Like, what is even CM? Like, can you give me the book? It's linked in the description. Yeah, like Jim just said. I guess it's just an interesting definition, I would say. I am not really like, I'm not completely convinced about this definition. I guess it's just, okay, we can write it like this. And I'm convinced that this will lead to some finite value. Most certainly. Since absolutely convergent. Let me just think. Right, so we know that this is uniformly convergent. We can use the m-test. We get that this whole thing is uniform. And then we have that. Yeah. So I guess if f is of the form of a series, then we can use this way to get like the coefficients. Okay, notice that the definition does not state anything about the convergence of the series. What series? Wait, what? Oh yeah, this series. Okay. It is the main task of this chapter to investigate these questions. Okay, sounds interesting. And their Fourier coefficients. It is convenient to indicate to what function the coefficients belong by writing things like another commonly used way of denoting the Fourier coefficients, blah blah blah. When we want to state a formula that f has a certain Fourier series, you assume that the series converges in the justification of the definition. They say that we haven't said when such a series converges. Wait, which series? Are you talking about this series? Marcus? I mean, yeah, well, I guess it is. This is uniformly convergent. I guess so. Right? I mean, if we define this to be some function g of t, and we can just use the m-test and find a bound. Maybe not. Okay, let's just move on. There are a certain number of alternative ways of writing the terms in a Fourier series. For instance, when dealing with real valued functions, the complex valued functions ei and t are often felt to be rather unnatural. One can then write and reshape the two corresponding terms corresponding to plus minus n. Let's go a and bn. In the special case n is equal to 0, we have only the term c0. Okay. If we extend the validity of the formula an, we see that a0 is equal to c. For this reason, the Fourier series is commonly written right. Yeah. It's called a real or trigonometric version of Fourier series of f. So when f is real, we can write it like that. Should be stressed that this is nothing but a different way of writing the series. It is really just the same series as in the definition. Terms in the series 4.2 can be interpreted as vibrations of different frequencies. For a series of heaviside converges to 1/2 at x0. Maybe that will be an exercise. Consider 1/2 a0 is the DC component. The term a1 has period 2 pi. The term with n is equal to 2 has half the period length. Yeah, obviously. These terms can be written in yet another way that emphasizes the physical interpretation. The reader should be familiar with the fact that the sum of a cosine and sine with the same period can always be rewritten as a single cosine. Yeah. With a phase angle. number such that this means that 4.2 can be written in the form right, so this is for a single AB. Okay, I guess so it is for A1 or AN, and BN. Called a physical version of first series. In this formula, one can immediately see the amplitude AN of each partial frequency. In this text, however, we shall not work with this form of the series since it is slightly unwieldy from a mathematical point of view. When asked to compute the Fourier series of a specific function, it is normally up to the reader to choose what version to work with. This is illustrated for all example. F da 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 and da da da. This leaves f of t undefined for t is equal to but this does not matter. The value of a function at one point or another does not affect the value of its Fourier coefficients. Get a function with period right, so the f of t needs to be absolutely Riemann integrable. Right, so it is Riemann integrable since the discontinuities are countable, right? Can we free to get to L2 and Hilbert space theory? If not the best during my undergrad. I think I'll do that next semester when I'll do measure theory. I have a course on that. But yeah. Alright, let me think. Is it undefined? I'm not convinced. E2 en to pi plus pi. Look, so this is equal to so we just have a period. So this would be equal to e pi. I guess we're not defining it at that point, right? pi to pi okay. This hyperbolic sign, here we use the fact that now we write f of d as the sum this is equal to this. Remind the reader of a couple notions of symmetry that turn out to be useful in connection with Fourier series. Function f defined in R is said to be even if function is odd, yes. An odd function f on a symmetric interval has the property yeah. Right, so here we have oh yeah. Satisfies f of t is equal to pi minus t divided by 2 for t finds Fourier series. Let's just see cosine So it's odd. So these will, so it's even. So the integral would be. Let me think. It's always with 0. Then I'm wondering, why do we get 2 divided by pi? Oh, yeah, of course. Yeah, okay. Sorry, I was looking at the wrong thing. Yeah, so it would be yeah, of course. Yeah. AM would be this, and then BN would be 0. Okay. Screen as given actually determines the function completely. Okay. Find the Fourier series. Okay. Series obtained is clearly convergent. It is even converges uniformly by wire stress. At this stage, we cannot tell that what its sum is. The goal of the next part section to investigate is for a moment we can notice two facts about Fourier coefficients. So put f is as in definition, then the sequence of Fourier coefficient is bounded. Alright, yeah, I mean it's kind of interesting. We're finding Fourier series without knowing anything about it. So we have that. I mean, this is kind of straightforward, I would say. Yeah, it's just I actually don't know, was it negative? I think so, negative IMT. And Fourier coefficients tends to 0 as n goes to infinity. Where is this supposed to be in? Yes, this is n instead. Does it tend to 0? It's just the lemma of the case of Riemann-Lebesgue lemma. Do I know the Riemann-Lebesgue lemma? Man, I kind of forgot this lemma. It is somewhere in the book, but let me just search it up and see if I can understand it. Plug in it. Alright, good night, Marcus. Yeah, hopefully good night sleep. So saying something is L1 is that maybe this will not be. Oh, it says here. IFRN to complex is a measurable function such that this norm defined like this is like this. Oh, so this is exactly the Riemann. Okay. Well, there goes the only mathematician in the chat. I take my words back. I'm also doing math. All right. But Marcus is like at the PhD level, so. But yeah, let's see here. So let's see the Riemann-Lebesgue lemma. Let's Riemann-Lebesgue. No. No. Oh. No? Bro, I promise it was here somewhere. Yeah, page 25. I'm Mr. Lonely. Hello, AK gamers. You are not alone. What? My golly. What the freak? Okay, so I guess this version of the Riemann-Lebesgue lemma is that the limit sign. Alright, so we have f. So f is absolutely integrable in the Riemann sense on a finite or infinite interval. Right, so this t is a finite or infinite interval. Okay, so yeah, so this is kind of cool. So I want to ask, what's time in your country? It's currently 10:42 p.m. I have a clock there if you didn't see it. Yeah, so if we have, so the limit, and yeah, it's interesting because in Wikipedia this is definitely not, oh, I think I deleted it, but this is definitely not how like the what the Riemann-Lebesgue measure is like the statement. Do we have the, I don't think it's absolute value. No, it is. So in the case where n goes to infinity, we have this, and then we can just rewrite this. So sine is even, so we're fine. And then we can rewrite cosine like sine, which is this. I think it's is it pi half minus t? Sine of this is equal to cos of t, I think. And then we can just, or does this work, I think? Because then we have Let me see the proof. Oh, it takes up like 2 pages. Yeah, I'm not sure if I want to spend that much time on this. But it's not maybe completely, maybe not, I'm not completely convinced. Maybe there is some, or okay. I can write cosine as sine to yeah, but then again, it's not really on, or yeah, I think this works actually. So we can write this as 2t divided by wait, let me think. Yeah, so it's divided by 2 sine of t. And then we know that this converges, or it's equal to 0. Then this maybe doesn't help us. Finish preparing from 1 minute talk. Introduce my poster during Berlin conference. Ooh, nice. Well, that's cool. When is the conference? Which digital device are you using to write on? I'm using a. I should probably write this. I think I've had this question sometime, like a couple times. But it's a Huion Q620. I think it's called. It's a Huion dial specifically. Week after next. Ooh, okay, so it's kind of soon. How long will it be? How many days? I have a feeling that it's a conference that spans like a week minimum. What did I want to do? Yeah, change setup. Writing tablet is Huion dial Q620. It's like a older model. Or no, it's Q620M. I said it wrong. I think there are better devices nowadays. Alright, it should be 2 days plus 1 day of hackathon that I'm joining. Oh wow, okay. Like you didn't sell your writing tablet? No, I mean I did sell the big one. Like if you go back to like the first stream I did, I had like a big like digital thing. That I did sell, but this one is, I mean it's for one very cheap. like for kind of a big device, like it's kind of huge if you compare it to my face. And it's also really good. I've had this for many years, maybe 6 years, and I've been very, very I haven't really kept it I haven't been careful with it, so it's been through some things, and it has a couple scratches and stuff, but it's still really good. Holds up very well, and it works with Linux and everything. It's like a very good device. Yeah, I'm really not. Yeah, I'm just gonna ask ChatGPT on this. I'm kind of stuck. So using this Riemann-Lebesgue measure lemma, how is it completely like? Wait. I mean, maybe if I go through the proof, it's probably not a big deal having a sine or a cosine. But if I want to respect the theorem, let me think. Yeah, I'm just gonna ask. Same holds with cosine. Well, I mean, to multiplying by a high frequency oscillating function averages to the integral out to 0. Maybe that's a good way of seeing it, yeah. By high frequency oscillating function. Yeah. It doesn't matter if it's a cosine or something. I guess that would be like a lemma, I guess. Okay, what exercises do I have? Let me look. Looky. No. Yes. .30 to 3.36. Or no, wait, I've already done that, I think. 4.1 to 4.3. Okay, 4.1. Let's do that. Let's go. Actually, what did the lecture even cover? Which chapter? 4.1, 4.2. Okay. So, have I done was this 4.2? No, this was just 4.1. use the formula, or prove the formula. Okay. 1/2 an minus ibn. Alright, so an is equal to 1 over 2 over pi of cosine of n t. I think this is correct. So I need to show that this is equal to can I write f of t e negative I m and t. Wait, maybe I'll just continue here. Right. Yeah, it's kind of clear, I think. And C negative n. Yeah. Yeah, I think this is kind of clear. Odd. So FG odd. H even. Find out which of the following functions are odd or even. Well, this is not an exercise, come on. What is a YouTube community? That's a good question. I don't really know. It was something... I don't really know, actually. Oh gosh, I just realized this thumbnail looks kind of horrible. Okay. Yeah. It was something that popped up when I clicked on post, when I wanted to make the post yesterday. But I think it's something like a Discord or something. Like you can, the community can post stuff and I can react to it. I think. Or actually, I don't know. No, I don't think that makes sense actually. Why would they do that? Okay, but this is a weird question. This is I'm just gonna skip that one. Am I missing something? Like, this one would be or I guess this one would not be even or odd. This is neither even or odd. This one would always be even, or no. Right. Yeah, so this one would be yes, this one would be even, or odd. I mean odd. Yeah. Sorry. Let's move on. Which one? 4.3. What are these questions? Show that an arbitrary function f on a symmetric interval can be decomposed as fe, fo, where fe is even, and show that this decomposition is unique, i.e. hint put, yeah. Yeah, I've already done this question. This was in one variable, I remember. So we know that this is even, so we can decompose everything. I'm wondering, symmetric, where f is a symmetric, on a symmetric interval. Well, I guess that makes sense, yes. Since we're doing the negation of t, if that were to be defined, we need this symmetric part as well. Right, so to define the odd, I think this is how you do it. So if you have f of t minus f of negative t, then this would be odd. So if you do negative, this would be, yeah, so this is odd, and this is even. And then you can yeah, so you add them together and then you get, so f of e plus f of o is equal to what is this? So or maybe I do the negative here and then just a positive there. Oh, it doesn't matter, sorry. These two take out each other and then we get f of t. And then we're done. And is this unique? So I guess assume f can be written as a decomposition of some other even and odd functions, or yeah. And then we have that and in this construction how do I show this? So find out which of the following factory. Show that this can be put. I don't really know. So assume that it can be decomposed into another even and odd functions, and I need to show that these are the same. It seems like it makes sense. So we have that if, how do I show this? So I need to show this, okay. It's the even plus f. Even is equal to f. Let's see. I don't really know what's Any smart people in the chat? Love the proofs in this subject, but hate the actual applications. Hello NNA team, welcome. Nice to have you here. Academy raid. We have a raid on the Twitch. Wait, who raided us? Or me? Alright, thanks for your raid, Academy of Useless Ideas. Well, that seems like a harsh name. Another math streamer. What? I didn't know, like, honestly, I haven't heard about anyone else doing these kinds of streams. Attempting math, hell is other people, but and it's also other people. Alright, well, thanks for the raid. What book is that? It's sorry, this my Twitch live is completely broken. It's called Anders Vretblad, and I think it's applications of Fourier analysis and its applications. All Fourier transforms, indeed. Let me change the titles to make sense on Twitch. I'm also live on YouTube, by the way, so that's why. Yeah, I've always started streaming on Twitch a couple what is it? A week and a half ago. Have you considered streaming on math category? We almost didn't see you there. Is there a math category? I think I'm streaming on just chatting, or yeah. Am I streaming often? I stream every day, or like 99.9% of the time. I just ended my 300 or 672nd like daily stream streak. But yeah, I'm still gonna stream like pretty much daily. Ew, here's the category. Wait, what? There is a math category. I mean, the thing is that math isn't really that much streamed that much on Twitch. I mean, there is a math category, fine, but I only see. Well, can I? And what do I stream? I stream. I used to do study with me streams, and now I'm doing math streams because I feel like it's more educational. Do you know category theory? haven't studied it. Yeah, I'm not really that. I don't really know what it's about, to be honest. Yeah, I'll follow you back, Academy. It's cool seeing another math streamer, honestly. Alright, anyways, so trying to prove uniqueness of these the even odd decomposition of a function, which is interesting. Study math or physics, something else? Well, I'm doing a math bachelor, so these streams will only be with math or regarding math. So yeah, I recently ended my physics bachelor's. Like I did my first year on physics and then also on math, but then I was kind of bored with physics, so I decided to switch to math, as one should, or maybe not, but it was more fun. I felt in physics you didn't really know what I didn't feel like I knew what I was doing, like regarding the math, which is I think very important. And there's also somehow there was a lot of beef between pure mathematicians and physicists, like my physics lecture and my math lecture. I mean, of course, friendly beef, but like, I don't know. I feel like it's weird. I'd rather not be in between. Like, I'll just stick to something like the math people. I think, yeah, just show that this minus fe, or wait, came from electrical engineer, I'm guessing, and I actually like math the most. Nice. I mean, we'll see if I'm like, there is a lot of competition, definitely, between like in the math field. I actually my high school teacher, at least at the math last couple months of high school, He was a PhD student in math, and when I asked him like why he's working as a high school teacher, he said that it's a very competitive, and then yeah, it was hard to get a job basically. Which, yeah, hopefully that's not my future. But we'll see. Can someone explain algebra? I mean, give me a specific problem. I'll try my best. And I think people in the chat are also kind of cracked at math. I guess I like math the most, but physics and engineer are great too. Yeah. I mean, definitely. I mean, I do appreciate applications, but it's just, yeah, for me at least, it's just fun for some weird reason. Yeah, I'll ask a hint on ChatGPT for this uniqueness. I don't know, I'm probably missing something. And I don't want to be stuck here for... I'll end stream in around 45 minutes, and I do want to get one more subsection in before ending. So give me a hint on showing uniqueness for even odd. Just a hint. Yeah, I mean, AI is a secret best friend. Do you prefer more theory or problem solving in math? I mean, problem solving is what you do. That's your business. So I mean, both. I mean, theory is problem solving. So yeah. I can think of multiple fields you could get into, although it would not directly be likely be math. Yeah, I mean, true, mystery. But this particular high school professor, teacher, was. I mean, yeah, sure. I'm not really sure. I'm guessing he didn't want to get into any other field. He liked teaching, which is, I mean, I do as well. But yeah. Suppose you had two different conversations into F. Subtract them. What function? Proofs are less problem solving and more understanding. I don't know. Maybe we have different definitions of problem solving, but I mean, certainly if you want to understand a proof, or if you're doing a proof, you have to problem solve. Yeah, it's like, I would say it's the essence of problem solving, doing a proof. Okay, so we know that f e plus f odd minus f e tilde minus f odd tilde is equal to 0, and we want to do something. Okay, let's just see. So evaluated at f of t, so f of negative t minus f of alright. Does it imply that, Marcus, 0 is both even and odd? Oh. Am I streaming on YouTube as well? I am. So if it's even and odd, doesn't mean that the let me think. I mean, look, if we add them together, or wait, let me think. No, if we just yeah, so yeah, that makes sense. If we just make equal them together, we cancel this, and we get or no, wait, what am I doing? Or yeah, no, we get something correct. Yeah. What's the uniqueness of decomposition for the function? Indeed, yeah. So I agreed, Marcus. Thanks for the help. I mean, you're always here, spitting. I mean, okay, yeah. that makes sense. You need to get to bed, Marcus. But I appreciate the support or the help. Yeah, ChatGPT gave me a very open-ended hint, which is what I wanted it to give me. Let's move on. I wanna get through chapter 4.2 as well. By the way, questions. What were the seminar? 4.5. Now let's sleep for real. I will be up at 6 hours. Okay. Good night. Good night. My gosh, my computer is screaming. I managed to split screen and open both chats on phone. Nice. You know, I mean, maybe it's like the downside of streaming on two platforms is that to be really in like to understand conversation and stuff, you need to be on both. I don't know. Anyways, and its complex Fourier coefficients. If f is even, then Cn is equal to C negative n for all n. So I guess let's do that. Okay, so let me use f is here. Okay, I think if we do this negative t, we can do u sub right, so we can do use right to get a negative. Yeah, or is it? I understand you can just change your variables, but in my head it's not really working out. I mean, you would get a negative term here. How would that die? Wait, let me just do it straight up. But wouldn't you would get like a negative term or like negative factor, like -1, right? So you do let me just do this carefully so I don't mess up. Or no, actually, yes. Okay. I'm convinced. Sorry. Yep. I am convinced. Okay. So if f is odd, then we have that. If f is a real value, then we have conjugate is equal to negative for all n where covers conjugation. Alright, I'll skip these and I'll just continue. They should be fairly straightforward. I was just kind of blundering here. Yes, okay, so exercise and then 221. Okay, let's move on. Dirichlet and Fourier kernels. It is a regrettable fact that a Fourier series need not be convergent. No! For example, it is possible to construct a continuous function such that its Fourier series diverges at a specific point. See, for example, the book by Thomas Kerner, mentioned in bibliography. If we impose somewhat harder requirements on the function, such as differentiability, the functions are more positive, or the results are more positive. It is, however, true that a Fourier series of a continuous function is Cesaro summable to the values of the function. Of a continuous. Well, I guess if something is absolutely Riemann integrable, the function is not necessarily continuous. Yeah, true. Yeah, that's obvious. To the values of function, and this is the main result of this section. The values. Alright, well that seems interesting. Start by establishing a closed formula for the partial sums of a Fourier series. This is defined to be equal to this, which is equal to that. Okay, which is equal to sine. Okay. So I compute it as a finite geometric sum. Okay. This is equal to this. Ew. Truly not at night owl. Alright, good night, Genius Grind. Yeah, hope you get good night's sleep. I think I'm gonna end the stream too soon as well, but first I want to get through this. This inequality is bugging me. Okay, I agree with this. Yeah, we can just we get n minus capital N, which goes through the same things. Okay, so we have this inequality. This is just a geometric series, or a finite geometric series, which we can factor this out. Yeah. And then we can. This is sine. Okay. Function Dn is the Dirichlet kernel. Its graph is shown in figure page 83. Oh, waves. Got it. When discussing the convergence of Fourier series, the natural partial sums are those containing all frequencies up to a certain value. Thus, we define the partial sums Sn to be Fourier is for continuous functions, so should nt be an integral from negative n to n. I should not, or I'm guessing you should not. I mean, first of all, Fourier is for continuous functions, so it's not really for continuous functions. It's on the next page. Alright, let's just continue. Yeah, I'm not really sure what you mean, but because we can define the Fourier series of a function without having the function be continuous. Yeah. I guess just as long as it's discontinuous on finite or on countably many points, then the Riemann integral exists. Yeah, so using Dirichlet kernel, we can obtain an integral formula for this sum. Assuming the Cn to be Fourier coefficients. Okay. In the last step, we change the variable t minus u, replaced with u, and make use of periodicity of the integrand. Let's see, so we can just substitute, and we can take out this. And alright, so we flip the integral and the summation, which is fine, I guess. Why is it fine? Well, let me think. Is it fine? Let's find. Yes. Yeah, so we're just factoring out this. Okay, yeah, it's fine. Guys, you decided to join Twitch too? Yeah, I think Twitch is like a cool platform. Yeah, it's you can always change for finite sums. Exactly. Yeah. That makes sense. Oh, we get that. Okay, interesting. Do we? We define it with this. Well, damn. We shall presently take another step and form the arithmetic means of n plus 1 first partial sums. To achieve this, we need a formula for the mean of the Dirichlet kernels, which is Fn. The mean. Oh god, okay. Proof can be done in a similar way to lemma 4.2 or in other way. In left on the x side, the function Fn is called Fourier kernel. By the way, what does kernel mean even? Like, what specifically makes mathematicians keen to naming stuff kernel in some cases? Let me just... Is there something obvious here? Because there is the... this... In the book they define something positive summation kernel. And in linear algebra you have your kernel as well. Like all vectors that map to like to 0 given a linear transformation. Not exactly sure why they call it kernel sometimes. Now we can form the mean of partial sums, which we denote sigma n. Lord have mercy. So S naught, which we made like this, which is the sum of these guys. We change variables, I guess. Yeah. And then it's the sum from 0 to n of this, and then we can reorganize, and we get the Fourier kernel. We get this. So I guess the goal is to show that this integral converges to show that this is equal to f of t. Okay, I don't know what I'm writing now, but it did say something here. Okay, I'll just read. Why am I assuming? The Fourier kernel has two properties, or the following properties. Fn is even, and this is 1. For delta positive, we have that the limit from delta is 0. part 1 is obvious. Number 2 follows from Fn is the mean of the Fourier function. Finally, property 3. We proved right by squeeze theorem. The lemma implies is a positive summation kernel such as the one in section 2.4. Oh, I guess that's why they call it a kernel. Well, shouldn't these bounds be from negative infinity to infinity? Applying corollary 2.1, we then have the result on Cesaro sums of Fourier series. Yeah. I think so, at least. Do we have it? We can sharpen the result of the theorem a bit. If f is continuous in an interval and I is a compact subinterval of I, then sigma will converge to f of t uniformly on I. I've seen kernels in a lot of different contexts, but never thought about the name. Yeah. I mean, in this case, I think, yeah, it's called a kernel because referring to a positive summation kernel. But I don't know if this is a famous like definition. I think they have different names. No, Wikipedia. It's a generalization of positive definite function. Oh, this is definitely not what I mean. This is some other stuff. Yeah, I think it's maybe called summability kernel. Yeah, I think this is what we satisfy certain probabilities below. Certain kernels, such as the Fourier kernel, are particularly useful in Fourier analysis. Related to approximate. Yeah, exactly. Yeah. Oh. Define t to be r divided by z. Okay. I'm just curious. This will probably have no effect in my life. So f is piecewise continuous on t and continuous at a point t then the limit of this is equal to f of t. Yeah, exactly. So I think what I wrote is, did I write that? No, wait. I wrote this. But rather it would be the limit of what? As n goes to infinity? Right. Of this, which is equal to f of t. Which is kind of funky. Definitely. It's piecewise continuous. Yeah. Kernel here does not mean the same thing as in linear algebra, the null space of a linear transformation. In this context, the kernel is just a special function used as a weight. Okay, they have no similarities. Thank you. So I guess it's like, okay. Okay, if a series is convergent in a traditional sense, then its sum coincides with the Cesaro limit. Oh yeah, we proved this before in the book, I think. This means that if a continuous function, it makes intuitive sense why the Cesaro limit would be equal to the limit of the convergent series. I mean, if it converges to a finite value and you take the mean of this, it would be the same value. If a continuous function happens to have a Fourier series, which is seen to be convergent in one way or another, then it actually converges to a function. That makes sense. In particular, we have the following theorem. So if f is continuous on t and its Fourier coefficients Cn are such that the coefficients are convergent, or I guess, okay, fine. Then the Fourier series is convergent with some f of t for all t in t. The convergence is even uniform on t. By golly. The uniform convergence follows using Weierstrass M test, just as the beginning of the chapter. This result can be applied to example 3 for previous section. For a series of this, applying the usual comparison test, we see series is easily seen to be convergent, and we know that its sum is equal to f of t. Holy crap, that seems very interesting. I should have this tattooed on my body somewhere. It seems very weird. But maybe it's too complex to actually be tattooed somewhere. I guess I can see why people would say that this is not really that nice of a formula. What is this formula hold even for t plus minus pi? Alright, well I'm not really going that deep into the text now because I'm quite tired. But yeah, we're almost at the end of the chapter. So yeah, I'll leave this for tomorrow. And yeah, so the stream is 3 hours. That was basically the plan. So appreciate everyone joining, and yeah. Cool. So yeah, tomorrow I'll probably... When will I stream? I don't have anything in the morning. Right, so I have ODE lecture. What will I do then? Let me just looky. I have... I shouldn't probably skip it. Yeah, I shouldn't probably skip it. It's a new parameter dependence. Monday. 5 parameter dependence. What the frick does that even mean? Okay, well, I'm probably not going to skip that lecture. It seems kind of important. I mean, some days I can if the chapter that is covered is fairly intuitive. But yeah, I'm not even sure what the lecture hasn't even put which chapters. So yeah, that's not really easy to follow what what will be covered, you know. So yeah, I'll see you guys tomorrow. I wish you guys a good night's sleep, or I don't know, a good day if it's like not late where you're at. But anyways, yeah, I'll see you guys tomorrow. I'll probably do a morning stream, or most likely, but evening streams could also work well, or maybe I'll do both if I really want to. So